isosceles, and equilateral triangles. What's going on work two? Okay, base angles theorem. You're gonna memorize this, right?
Yep.
I mean,
I would suggest it.
you want me to.
Yeah, you don't have to. I'm gonna make you, but I would suggest you memorize it.
I don't feel like it.
So what that says is, if two sides of a triangle are congruent, then the angles opposite them are congruent. Two sides of a triangle are congruent, then the angles opposite them are congruent. Base angles theorem. Two sides of a triangle are congruent. Then the opposite angles, the angles opposite them, are congruent to each other. That's what that means. And we're not talking about two triangles being congruent to each other. That's not what this is. So don't confuse that. So if you have an isosceles triangle, that means your opposite angles are congruent to each other. Okay? Any questions? Anybody not understand that? Who can tell me what the converse of this theorem is?
If two opposite angles are congruent, then the two sides of a triangle.
Good. So if you're given these two angles being congruent in a triangle, then you know the sides opposite them are congruent to each other. All right. So and that's an actual theorem. So the theorem 4.8, I'm not going to write it out. That's the converse of the base angles theorem. I'm not going to write that out. You should know by now how to write a converse. All right, how about we do a corollary? Corollary to the base angles theorem. If a triangle is equilateral, what's equilateral mean?
Equal sides.
Equal sides and equal
Angles.
because of this corollary. So you've already accepted what equilateral is. We've not talked about equilateral triangles yet, have we? Okay, so this is key. You realize you're getting caught up with a lot of things you've already learned. So if a triangle is equilateral, it is equiangular. Now you can actually say that. That's what the corollary is. You've known it all along, now you actually have something. You couldn't have said it before. Use congruent triangles to figure it out, but given one triangle, if all the sides were the same, until now you couldn't have said that the other angles are all congruent. But now you can say that. What do you think the converse of the corollary to the base angles theorem says? Or not?
If a triangle is equiangular, then it's equilateral.
Yeah. If it's equiangular, then it's equilateral. So given three angles being congruent in a triangle, you know the sides are congruent to each other. Okay? Any problems? All right, so let's put that to use in some examples. Example 1. Here's your triangle. This is a generic triangle. I'm not necessarily saying anything about it. Oops. What do you think x equals? 4. Good. Why is it equal 4? Tell me why. Yeah.
The theorem 4.7.
I don't know what theorem 4.7 is.
base angles.
The base angles theorem, yes, thank you very much. Base angles theorem, converse, right? Converse to the base
Yeah.
angles theorem. So given the angles, that means the sides must be the same. So x equals 4 here. Example 2. How about this one? What is x equal?
What's the thing above the x?
A degree.
Oh, I couldn't see it. Well, thought it was x to the power or something.
No, I mean that's what a degree looks like. I guess if you want to get really technical. Is that better? Yeah.
X equals 60.
Why is it equal 60?
Because the triangle has 180 degrees, and since it's equilateral, it's equiangular, corollary to the base angles.
Yep.
Yeah. So 60 plus 60 plus 60 is 180.
Yep. Very good. 60 degrees. Alright, example 3. This angle is 75 degrees. This is 5x degrees. These two sides are congruent. Tell me what x is. We zoomed in close on these.
Yeah.
Unless it doesn't focus, that's fine.
It's zoomed in like enough so you can see it.
Nate, how you figured out? Or what'd you get for an answer?
x5 equals, or 5x equals 75 divided by 5.
5x equals, how do you know 5x equals 75?
Because of the base angles. Theorem.
The base angles there. The two sides are equal, then the opposite angles are equal, are congruent. So 5x equals 75 divided by 5 to 15. Is that correct? Not 15 degrees. X is not degrees, x is just a number in this case. Okay? And the last example, example 4. This is 130 degrees. This is x. This is y. I didn't draw it perfectly on purpose. I want you to get used to that. I want to know what x and y are.
25 degrees
How do you know that?
because of the base angles theorem.
Base angles theorem, what does that teach you?
Or that if two sides of the triangle are congruent, then the angles opposite.
So x equals y. Good. That's true. How do you know it's 20? How do you know they're both 25?
A triangle equals 180 degrees.
Yes, 180 degrees. Good job. So 180 minus the 130 equals 50 degrees that are left. And since both angles are the same, that's really 2x. Y is the same as x. X plus x equals 2x, and 2x has to equal to 50. So that's why x is 25 and why y is 25. Gotta be able to write it down in your own words, okay? Okay, the assignment, page 267. 3 to 37 odds. We'll shoot for mixed review. Is anybody done with mixed review? Are you guys done with mixed review? Did you do note taking guide too? Okay, we're good.